All right. Cool. Yeah, thank you for that introduction. I'm very excited to be talking about how to stop sharing kube configs. Right. So it's very common. You'll see it all the time. Many people or across a whole engineering team, they might all be sharing the same kube config that does not expire. Everyone has access to be part of the system masters group or some kind of admin group. Not a lot of native Kubernetes role-based access controls that are being used. So what I'll be talking about is how you can use open source teleport to stop sharing kube configs. And with teleport, teleport will actually issue short-lived kube configs that are based on the role that you have within your organization. I'll also be talking about just in general best practices for securing Kubernetes clusters, and everything I'll be discussing is completely open source. So every capability I show in teleport, every tool I show is all fully open source. So the agenda for what I'll be discussing today, I'm going to start with just a very high level overview of security, discussing things like attack surfaces, security architecture, zero trust concepts. I'll then move into speaking about using a unified access plane or an access gateway for accessing infrastructure. Then I'll move into talking about native RBAC capabilities within Kubernetes. I'll then provide an overview of my demo environment, followed by a demo. And lastly, I will answer any questions that have been added to the Q&A portion of this Zoom. So we're going to start with some theory, move into some architecture, and then hopefully a cool demo, putting it all together. So in this section, I'm going to define a few key security concepts so that we have a common set of definitions to work from. So attack surface, this is the first definition. According to NIST, an attack surface is the set of points on the boundary of a system element, or an environment where an attacker can try to enter, cause an effect on, or extract data from that system element, or environment. So in other words, an attack surface describes all the potential vectors for exploitation. And in this slide, I'm going to be discussing the different technology layers that you'll typically find within an organization. And as you look at each layer, you'll want to perform one of those attack surface analyses for each one. So the first, networks and infrastructure. Some questions to ask around this are, how are users and devices accessing your networks and servers? Is SSH being used? Applications. What applications are running in your network? Who has access to those? How are those being secured, as well as the underlying operating system and host? How is data being protected? Endpoints. How do you control which users are authorized to access different parts of your environment and your network? And then cloud. Are there open S3 buckets? Are API keys being shared or not rotated? And when we're talking about Kubernetes, a Kubernetes deployment can cover all of these layers. So it's really critical to think about how you can properly secure your Kubernetes server API, the applications running in your clusters, the infrastructure the clusters are running on, and the endpoints your users are accessing the Kubernetes clusters from. The last high-level security concept I'll mention is zero trust. So zero trust is a model that was developed in response to NIST's request for feedback to a document called Developing a Framework to Improve Critical Infrastructure Cybersecurity. And according to the analysts at Forrester, the three main concepts of zero trust are, see them here, one, ensure all resources are accessed securely regardless of location. to adopt a least privilege strategy and strictly enforce access control. And then lastly, inspect and log all traffic. And so how Teleport can help fulfill each of these concepts at a very high level is Teleport's using end-to-end TLS encryption. It's using certificate-based authentication for every component. Open source Teleport can map GitHub teams to groups and users that exist within the Kubernetes clusters. So within the RBAC that you've set up within your Kubernetes clusters. And then all kubectl requests are actually logged, and all kubectl exec sessions are even recorded by Teleport. And so when we get into the demo, I'll be showing some of that. So now I'm going to discuss using a unified access plane. And when you talk about Kubernetes, the odds are is that you will end up with multiple clusters. So you might have your development, your staging, your production clusters, etc. Or maybe you have multiple clusters per region. But in order to deal with all of those, you really want to centralize the access. So you want to avoid having multiple backdoors, multiple ways of accessing different clusters. So you really want to pipe all of your developer access to your clusters through a single choke point so that you can enforce your security policies on that point. So you can think of this as a gateway. And so that gateway is a great place to attach to your SSO identities any requests and any modifications, so that any action that's occurring across your network, across your Kubernetes stacks, that's all actually being tied to somebody's specific identity as it is within SSO, within your IDP. And so that way you get accountability and user attribution from everyone in your organization about who is doing what, when, from where, and in what environment they're doing those actions as well. And you really want to make sure that the gateway is only allowing SSO users through and records their identity with their requests. So that's again avoiding that all these different shadow IT accessing different means of accessing infrastructure that the IT or security teams might not even be aware is there. And so the other thing is, even though you're using Kubernetes and it is hiding a lot of the underlying hardware and infrastructure, especially if maybe you're in GCP, Google Cloud Platform, you're using the GKE, a lot of it is maybe hidden from you in some respects, but it really is all still there. The servers are still there. You have applications running in your clusters. There are still operating systems on those servers. And most likely you still will manage everything under Kubernetes via SSH or something similar. So you really don't want to forget about those other access aspects. So you really want to make sure you do all of the same enforcement that you do for Kubernetes. So attaching SSO identities to all of your access control. So don't forget about SSH or any internal applications that you have running, databases, etc. And when using your SSO identities, make sure that you map users and groups that exist within your IDP, within your identity provider, to users and groups that you create within your Kubernetes clusters. And those groups and users within Kubernetes, they can be created using native Kubernetes role-based access control, which is what I'll be moving into next. And as far as setting up that mapping of groups and users within SSO to groups, users that exist within Kubernetes clusters, I'll be showing how you can use Teleport to set up that mapping. And so this is where we get into really how to stop sharing kube configs by implementing role-based access control. So another definition here, just to make sure we're all on the same page. Role-based access control, or RBAC, is a method of regulating access to computer or network resources based on the roles of individual users within your organization. So really use least privilege and grant access based off of a user's role within your organization. Now, this slide discusses the differences between roles and cluster roles in Kubernetes. So again, a couple more definitions, and then we'll get into the fun stuff of the demo. But a Kubernetes RBAC role or cluster role, they contain rules that represent a set of permissions. And those permissions are purely additive, so there aren't any deny rules within those. And a role in Kubernetes always sets permissions within a particular namespace. So when you create a role, you have to specify the namespace that that role belongs in. Then a cluster role, on the other hand, is a non-namespace resource. And the resources, they have different names, role and cluster role, because a Kubernetes object either, well, it always has to be either namespaced or not namespaced. It can't be both. So if you wanted to find a role within a namespace, you should use a role. And if you wanted to find a role cluster-wide, you should use a cluster role. And in my demo, I'll demonstrate using a Kubernetes role to limit a group to a single namespace rather than using a cluster role. So now into an overview of what my demo environment actually looks like. So what I've done is within GitHub, I've created an organization that I've called Kubernetes org. I've then created 2 GitHub users, one that's an admin user, one that's a dev user, and I've created 2 teams within my GitHub organization. My user is going to be a member of both the admin team and the dev team, whereas my dev user that I've created is only going to be a member of the dev team. And how I've set up the mapping of teleport roles to this dev group that I created in my Kubernetes clusters is that my dev team is going to be limited to the dev namespace within my Kubernetes clusters. And I've set up 2 Kubernetes clusters behind my teleport cluster, as well as 2 internal applications. And I've enabled SSH on one of my Kubernetes clusters, but only the admin user has the ability to SSH into that Kubernetes cluster. And then lastly, I'm using Let's Encrypt for signed HTTPS certificates. So from these users' perspectives, what it will look like is they want access to some piece of infrastructure down here. I'll focus on Kubernetes. But these components, they are in completely private subnets. These users do not have direct access to any of these. From their perspective, they will actually go through this teleport proxy to access these items down here. And the tools that they can use are, they can use TSH, which is a CLI tool from Teleport. They can use regular kubectl. And they can also use a UI that's being served from this proxy. So regardless of which tool they use to access something down here, it is always through this proxy. The other component, and these 2 components, this proxy and auth, they are on one single EC2 instance that I have in AWS. The other component is this authentication. And this is where my certificate authority lives. This is the thing that is signing and issuing short-lived certificates. This is also where all the robust audit logs are going to go by default. And from here, I can easily send them to some kind of SIM or other log server that I might have. But from these users' perspectives, the first thing they do is they go to this proxy and they do an SSO login. So back to my point earlier, they're not using yet another means of authentication. They're going to use the same SSO login that they use for everything else within their organization. And so based off of their team membership, they're going to receive some role from Teleport. And it's within that Teleport role that it's going to specify how long their access is good for and what they are allowed or not allowed to access. And they receive short-lived certificates. In the case of Kubernetes, they will actually receive an updated context and an updated kube config that is mapping them to a specific group or user within Kubernetes clusters. And that's of course configurable if you wanted to map multiple groups and users to some user. But for the purposes of this demo, I'm keeping it very, very simple. So to move into the actual demo environment, let me switch over. So I have two web browsers that I'll be primarily working from. So in this Safari web browser, this is where I'm logged in as a dev user. So here, logged in as the dev user named dev account dev, nice and straightforward. And you can see that this user is a member of the Kubernetes organization, and their team membership in GitHub is this team called devs. If I go over to my Firefox browser, this is where I'm logged in as my admin user named admin account admin. And you can see also a member of the Kubernetes organization, and their team membership within GitHub is this team called admins. So if I switch over to my teleport proxy, this is its URL, I've set up an OAuth application so that I can use my GitHub credentials to access my infrastructure. So since I'm in this Firefox browser where I'm logged in as my admin user, if I click this GitHub login, it's going to log me in as, you can see, admin account admin. So what I see now is I can see two SSH servers, I can see host name information, I can see labels. And where labels come into play is you can specify within a teleport role that in a given role, somebody can access or not access a piece of infrastructure based off the labels that you associate with your infrastructure. And then over here, this connect button, this is a drop down of the OS users that I can SSH as into these two servers. And this is also coming from the role that I received when I authenticated and logged into this teleport proxy. So just to show you very quickly how I actually set up the mapping of my GitHub teams to teleport roles, let me go here into Teams, Auth Connector. So this is the GitHub connector that I set up. And the part to focus on is this. So what this is saying here, this is mapping roles to teams that exist within my GitHub organization. So this one says here that if somebody comes along, they authenticate against this GitHub connector, they're in this organization, they're in this admins team, they are going to receive this teleport role called admin. Likewise, somebody else comes along and their team membership within the GitHub org is devs, they are going to receive this teleport role called devs. So I'll leave that up just for a second. So again, this is how you map teams in GitHub to any roles that you create within teleport. And it's within the teleport roles, that's where it's specified what somebody is allowed to do, not allowed to do, what users they can SSH as, all that stuff. So again, here, if you look at my servers, you recall there are these 3 OS users that I can SSH as. And because I'm in the admin team, again, I'm in this admins team, so I get this role called admin. If I take a look at that role called admin, view this. So there's a lot of ***. So this is an admin role. I've set it up to have a lot of permissions. But in here, you can see that when I'm interacting with my Kubernetes clusters, I get to be part of the system masters group as this admin role. I can access all Kubernetes labels. I can access all SSH servers. And this is actually where those 3 SSH user logins were coming from. So I've hard-coded these two, but I can also use this variable. So this is how I'm able to SSH as my GitHub user. And then down here, one other thing I'll highlight, this is the time to live. So when I authenticate as this admin user, I will receive SSH certificates that are valid for 12 hours. I will also receive a kube config that's valid for 12 hours. And just to do a very quick demonstration of some of the logging capabilities that I get in here, if I do a quick SSH into this server that I have here, I'll just SSH as root, right? Do whatever kind of sysadmin fun stuff I want to do in here. And then if I exit out of here, and if I go to look in my audit logs, so I can see at a high level, starting with this SSO login. So again, every action is going to be tied to this user's identity, everything that they're doing. I can see that they are starting SSH sessions, but not only can I see that they are SSHing as root, but I can see their IP address, I can see time, and it's all tied back to their identity as it is within SSO. So one of the other hats that I wear outside of Teleport is I'm a cyber operations officer in the Army National Guard. So I primarily deal with a lot of incident response missions in that role. And the thing that's extremely difficult for us is attribution. So figuring out, who actually has access, who has access to logging in as root. Who is sharing SSH keys, where are public keys located across infrastructure, who's sharing passwords, etc. So it would make my life so much easier to have something like this where I can see not only is somebody logging in as root, but here's the specific identity on who's doing that. And if I go here into session recordings, this is where we're capturing and storing all of these sessions. So this is the one that I just was in. I can pause, scroll around. I can also play this back in the CLI. And I mean, this is great for audits if you're trying to achieve SOC 2 compliance. This is even really helpful if you want to share how you configured something, because you can come in here and just copy from this, paste it somewhere else. And in addition to capturing these SSH sessions, you can see down in here, I was kubectl execing into this Kubernetes cluster into the default namespace, and this was the actual pod that I execed into. So we're even capturing everything you do in a pod. Same idea too. You can copy, paste, scroll around, do all that. So what I'll do now is I will actually show you using kubectl and what happens when I log in on the CLI. So let me go into my terminal window here. And before I actually log into my proxy in the CLI, let me just do a kubectl get pods. And I'll show you it's telling me, hey, something's wrong, you can't access this. So I'm not logged in to a teleport proxy, so I do not currently have a context with something that allows me to interact with Kubernetes clusters. But if I go back to this login, so again, TSH is Teleport's CLI tool. I can log into this teleport proxy. If you notice, it's the same URL I was interacting with back in here in the UI. Browser none. By default, TSH is going to open my default browser and initiate SSO login that way. But since I'm showing two different browsers, I don't want that behavior. I'm just going to suppress the automatic browser opening, just get this URL. I'm going to copy, paste this into this same browser where I'm logged in as this admin user. I have a successful login. So if I return to the CLI, you can see again, I've logged in as this admin account admin user, this cluster. These are the roles, the teleport roles that I receive. These are the same 3 OS logins that I can SSH as. And I'm currently logged into this Kubernetes cluster. These are the groups I get to be a part of in my Kubernetes cluster. And my access is valid for about 8 hours. So to see all the Kubernetes clusters that I have behind my teleport deployment, I can do TSH kubels, and I can see I have this current context that is being pointed to. I can easily switch to this other cluster if I need to. But now if I do a Kubectl get pods, it's actually going to return stuff for me. And now all of my Kubectl actions that I take are being logged by teleport. So if I go back into the UI, take a look at audit logs, you can see that now there are these Kubernetes requests that have occurred. I view details, information. This was a get, pods, this was the namespace, etc. So far I've showed you everything as this admin user. What I'll switch to now is that dev user. So I'm going to do tsh logout. And let me switch to my my Safari browser, which is where I'm logged in as this dev user. And so if I go to this same UI and log in as using this GitHub connector, so you can see I've logged in as this dev user, and in this case, I can only see this one server, whereas if you recall when I was logged in as this admin user, there are these two servers. In addition, if I were to click this connect button, I can only SSH as this one user, whereas my admin user, they have all three of these logins. And where that's coming from is from the role that I received when I logged in as this dev user. So again, very quickly, if I show you this auth connector, the dev user, they're in this dev team, they get a role called devs. So let's look at that role called devs. Devs role, let's take a look. And what I can see here is this devs role is a little more restrictive. This person is only allowed to SSH into servers that have this one label. They also can only SSH as this one user. Again, this is a variable that becomes their GitHub username. So let me go back into my Safari browser where I'm logged in as the dev user, right? Only see this one node because I can only see nodes that have this one label here, and I can only SSH as this one user. So if I now come back in here and I do a login, but I use my Safari browser where I'm logged in as this dev user, go into my Safari browser, put that in here, successful authentication. So I can see now I've logged in as the dev user. The role that I received is devs, can only SSH as this user. I've received a kube config, also valid for about 8 hours, but the only Kubernetes group I'm a part of is this group called devs. So if I were to do just kubectl get pods, this is in the default namespace, it's going to fail for me because that's not permitted for the devs Kubernetes group. And if I show you how I actually created that devs group within my Kubernetes cluster, I'll show you my role that I created and my role binding. So here is my role. This role is saying that let's call devs access, and it can only do these actions, these verbs on these resources in this one dev namespace. And then where I actually bind this role to a particular group is in this role binding. So you can see that here I've created this group called devs, and this is where I'm referencing this role up above. You can see that I'm referencing this role devs access, that's the role. So this group devs is only going to be able to do these rules in this dev namespace. So if I now add namespace of dev, so now I can actually do stuff. So that's again because I've set up a mapping of teleport roles to teams that exist in my GitHub organization, and it's within the teleport roles that it's going to specify what Kubernetes groups I can be, what labels I can access, all that kind of stuff. So that concludes at a very high level, using Teleport to get robust audit logs all mapped to a user as it is within SSO, as well as how to restrict users to particular groups or users within Kubernetes clusters. And again, when I authenticate, when I log in to Teleport in the CLI, I am getting a short-lived kube config. And so when I do a TSH log out, this is the same as my session expiring, my certificates expiring. If I try to do this kubectl again, it's not going to work. It's failing for me. So let me switch back over to my slides, my Chrome browser here. So to summarize what was covered, remember that Kubernetes expands the attack surface of your environment. So if you introduce a new layer, you have to make some other layer less relevant. So that includes turning SSH off for the majority of your engineering team. Really limit who has that kind of access, because having both present can increase the probability of you getting compromised. But if you do have SSH access enabled in your Kubernetes cluster, be sure to apply role-based access controls like was discussed in that demo, and then synchronize the two so that everyone in your organization has the same authentication gateway and the same access gateway. So again, that means not introducing new means of authenticating into infrastructure. It means using the same authentication that everyone is used to, so the same SSO login. And then access to all of your different environments, dev, prod, etc., should all be controlled through that same gateway, and role-based access control tied to your SSO identities should be used. And also be sure to regularly inspect and audit all access. And lastly, kind of the point of all this is please stop sharing kube configs. Create groups, users, use Kubernetes native access controls, and ideally you can use a tool like Teleport to give you short-lived kube configs that will map yourself to the groups within Kubernetes that you set up. So some recommended next steps, if you want to learn more about best practices for auditing Kubernetes, we have this on YouTube. Please also check us out on GitHub. And also, we are hiring. We would love to have you join us if you're excited about open source technologies, Kubernetes, databases, all that fun stuff. Please check out our openings here. And so this concludes my presentation. So now let me take a look at the Q&A section, see if there's anything in there. Let me take a peek.
Hi, Jonathan.
Hello.
Thank you. Yeah, thank you for that session.
Yeah,
I
absolutely.
don't think I see any questions. Please, if you have any question for Jonathan, please put it up in the Q&A.
So something that I do get asked kind of frequently is how do you actually deploy Teleport into Kubernetes clusters? There's a few ways of doing that, but the one I recommend, the most common way, easiest way, is we have a Helm chart that will essentially deploy Teleport pods into your Kubernetes clusters. And then those Teleport pods will establish a reverse tunnel back to your Teleport proxy. So essentially all of your kubectl requests will be through that reverse tunnel. And that's how you can
Jonathan, you have a question here. You have a question of said you mentioned databases. What database does Teleport work with?
So currently Postgres and MySQL And that includes, RDS within AWS, so Aurora. And on our roadmap, we are working on a lot more. MongoDB is going to be our next one. Database access became available, I think, this month in our 6.0 release. So yeah, definitely excited for people to try that out. Yeah, any other questions I can answer?
I do not see any other questions.
Awesome. Well, if there are no more questions, I'll hand it back over to you. And if you think of questions outside of this, feel free to reach out to me, Twitter, LinkedIn, email, whatever. I'm happy to answer what I can answer. And we do have a vibrant open source community, so feel free to join our Slack channel and participate in that as well.